Welcome to today's training. Today we are going to talk about UAV basic knowledge. We have 4 topics. The first one is introducing the UAV generally. The second introduces the basic systems inside a UAV, including flight control, propulsion, etc. The third one is introducing the default control stick mode for the DJI drone. The last topic is introducing the DJI Enterprise drones payloads or camera types. UAV is short for Unmanned Aerial Vehicle, which is often used on formal occasions. You may also hear of UAS, Unmanned Aerial System. UAS also includes the pilot as a whole system. Drone is the most commonly used word in media. Most of the time, it has the same meaning as UAV. There are several types of UAV. Single rotor, such as a helicopter. Multi-rotor, which is the most common for consumers. And there is fixed wing type. Generally speaking, single rotor and fixed wing are difficult to operate and their size is big. On the other hand, their battery can last longer. On the other hand, there are some benefits for multi-rotor UAV. It's easy to operate and a simple mechanism structure can bring us low cost. The ability to take off and land vertically means it can work in more situations. You should also know that most of the time, the UAVs act as an aircraft and carry a mission payload or camera for a certain purpose. Next, we are going to talk about the main systems of UAV. DJI UAVs usually contain the following systems. We will introduce them one by one. Flight control system is like a brain of a UAV. It can analyze all data from the sensors such as position, direction, attitude, and then gives orders to the aircraft, which can decide the speed of each rotor, fly to which direction, ascend or descend. The first essential part is GNSS. GNSS is short for Global Navigation Satellite System, and GPS is one of the most famous GNSS. Just like your smartphone, UAV receives signals from the satellite and calculates the position. In short, GNSS can tell the UAV, "Where am I?" The compass detects the Earth's magnetic field and gets the nose direction of the aircraft. Remember that the magnetic field is easy to get interfered, so you may need to perform a compass calibration sometime. In short, compass can tell the UAV which direction am I facing. IMU use the accelerometer and gyroscope to measure the acceleration and rotation, which can be used to provide the attitude information and let the aircraft keep stable and level in the sky. In short, IMU can tell the UAV, "How is my body moving?" Now we are going to play a short video about the flight control system.
Flight control system is like the UAV brain, controlling different components of the aircraft. By analyzing the data from different sensors, this system determines the aircraft position, altitude, flight direction, and other parameters to maintain stable flight and execute the pilot's commands. The flight control system includes a controller, magnetic compass, GPS, IMU, and other components. This system acquires longitude and latitude information through GPS to map the aircraft's position. The magnetic compass is used to get directional information to determine which way the aircraft's nose is facing. The IMU is used to gauge the aircraft's flight status and attitude information. After acquiring various flight data through the components above, the flight control system will calculate and interpret the data, allowing the aircraft to respond to commands and maintain its balance.
Propulsion system includes ESC, motor, and propellers. It's like the engine and wheels of a car. Take multi-rotor UAV as an example. The aircraft can ascend, descend, forward, backward, or even hover in strong wind by adjusting the speed of each propeller. Motor is easy to understand. It converts the energy from the battery, rotates the propeller, and the aircraft gets the lift force. ESC can control and adjust the speed of the motors, performing an acceleration or a brake. When ESC gets a signal from the flight control system, it can raise or lower the voltage to the motor as required. At the end, changing the speed of the propeller. Propellers on the UAV are easily worn parts. Please remember to do a visual check and unfold them before each flight. For safety reasons, you should change to a new one even with tiny cracks. Most DJI Enterprise drone comes with spare propellers. For the Matrice series, such as M300 and M30, you need a screw and a glue to change the propellers. Let's watch a video about the propulsion system.
The propulsion system ensures that the drone remains stable while airborne. In this section, let's have a look at its main components, including the motor, ESC, and propellers. The motor is a device for energy conversion that turns electrical energy into mechanical movement and allows the drone to gain lift force. These multi-rotors typically use brushless motors. In the UAV system, the main functions of ESC include controlling the motor rotation, adjusting the motor's rotational speed. Because the propellers are the most used items, they are susceptible to wear and tear. Here are some suggestions for properly maintaining the propellers. Check regularly. Be sure to check the propellers regularly and change any propellers with cracks or visible damage. Unfold propellers before flight. For foldable propellers, make sure they are fully unfolded before flight. Ensure propellers are secured. For foldable propellers, please make sure that they are properly mounted and secured. Regular replacement. Replace the propellers regularly according to their conditions to ensure flight safety.
When we talk about the communication link system of UAV, it usually includes three parts. Control link can send orders from the controller to the aircraft. For example, aircraft movement, gimbal movement, or data collection, such as photo taking. Image link can let the aircraft send the image information back to the controller. New models can achieve up to 1080p resolution. Data link can let the controller download the media files from the aircraft before landing. DJI Enterprise drones use O3 Enterprise transmission protocol. The transmission distance can be up to 15 kilometers and real-time auto switch between 2.4 GHz and 5.8 GHz. There are several tips for keeping a good signal. The first one is keeping both the aircraft and the controller at the latest firmware. The second one is keeping the antenna and the aircraft parallel, because the top direction of the antenna has the weakest signal, so don't point at the aircraft. Let's play a video about this topic.
The communication link system can be compared to the nervous system of a human. It transmits signals, receives the aircraft's feedback information, and sends out commands. The UAV communication link system is comprised of the following parts. Number 1. Control communication link. The remote controller sends out a control signal which the aircraft receives. Number 2. Image communication link. The aircraft sends back imaging information acquired by the payload. Number 3. Data communication link. The aircraft sends out data to the remote controller, giving the pilot information about the aircraft's flight status and payload. In order to ensure normal function of the communication link system, please pay attention to the following points. The firmware version of the remote controller and the aircraft must be the same. To avoid communication errors, always make sure the firmware versions of the remote controller and the aircraft are updated to the same version. The antenna must be unfolded. If the antenna is not unfolded, the transmission effect and range may be affected. Do not point the antenna towards the multi-rotor. The top and bottom parts of the antenna feature the weakest signal, so try to keep the antenna and the aircraft parallel and point the antenna upwards while using the remote controller.
Next, let's talk about the sensing system. DJI usually use the visual camera and infrared sensor on the aircraft. With these sensors, the aircraft can recognize obstacles and avoid them. About visual cameras, you can see 2 cameras on one side for most models. The system can calculate the distance by comparing the image difference between 2 cameras. On the other hand, low light or night situation, glass or water surfaces are dangerous for a UAV because the visual camera cannot work as expected. Even in daytime, you should remember that some models have blind spots in visual sensing system. Mavic 3 Enterprise series uses ultra-wide cameras so they can achieve omnidirectional sensing and have no zero blind spots theoretically. Infrared sensors use the infrared signal to detect the distance, which is more accurate when it's close to the surface. Matrice series have 6 directions of infrared sensors, while Mavic 3 Enterprise series only have the downward for landing safely. Although the UAV is equipped with a powerful sensing system, but it still has some limits, such as monochrome and highly reflective surfaces, strong light or low light, flying too fast, etc. This means that you cannot 100% rely on the sensors and should pay attention during the whole flight. The next video is created several years ago. You can focus on the visual and infrared parts.
Like the human eye, the perception system receives the environmental information via visual, ultrasonic, and infrared sensors or millimeter wave radar. Binocular vision simulates human vision through a set of cameras that observe an object from 2 points to acquire images from different viewpoints. With these images, the 3D information of the object is calculated by triangulation. Ultrasonic sensor, infrared sensor, or millimeter wave radar calculates the distance to an object by triangulation based on the time difference between signal transmission and reception. With the combination of the perception system and the flight control system, the speed and attitude of the drone can be calculated in real time. The location of the drone in the air can be tracked, and a 3D map around the drone can be drawn. In this way, the drone can perform positioning, obstacle avoidance, identification, and following when hovering and flying at low speed. The binocular vision can only function in an environment where object surfaces are textures and the light is sufficient. Environments with a greater deal of water, glass, or other smooth surfaces will affect the operation of the vision system. The infrared sensor requires objects to reflect light in a diffuser manner, such as walls, trees, and human bodies.
Positioning system is essential for UAV, especially centimeter level accuracy for the enterprise application. GNSS refers to all navigation satellite systems around the world. The most famous GNSS nowadays are GPS from USA, Beidou from China, Galileo from EU, and GLONASS from Russia. The latest DJI Enterprise drones support multiple GNSS at the same time to increase the positioning performance. GNSS is a one-way broadcast and can be easily disturbed. The signal travels through several layers of the Earth's atmosphere and gets measurement error. If you only get signal from one satellite, you can only know the distance between you and the satellite, which is not enough to calculate the latitude or longitude. For DJI drones, you need to get the signal from at least 8 satellites to take off, even though the accuracy of the GNSS can only achieve meter level. To achieve centimeter level accuracy, you need some new technology such as RTK. Because of the errors, you already know that GNSS cannot provide positional data better than meter level. RTK can solve this problem with a base station nearby. The base station is placed on a known point, so it knows the difference between the real position and the data provided by the GNSS, and keeps broadcasting this base correction. There's another important theory that the error is the same if two locations are close enough, like 10 kilometers. So the aircraft can get the GNSS signal with error and the base correction from the RTK station. Then it can calculate its location with centimeter level accuracy. Nowadays, there's local service providers with their own stations, and they share the correction data through the internet. It's called the N-trip. This is a quick explanation of RTK.
Global Navigation Satellite System is also called GNSS, used for position navigation and time synchronization on a global basis. By using a navigation satellite to transmit signals to the object, the distance between the object and the satellite can be calculated with the transmission speed and the transmission time. When 4 or more satellites transmit signals to one object at the same time, the distances between the object and satellites can be calculated. The position of the object is given by the intersection point of the circles by drawing with the satellites as the centers and the distances as the radiuses. GNSS provides many advantages, such as a short observation time, 3-dimensional coordinates, easy and round-the-clock operation, and more. China's Beidou, America's GPS, Russia's GLONASS, and the EU's Galileo are the most commonly used. However, GNSS probably suffers from positioning errors for various reasons. For example, satellite signals will be refracted when they pass through the atmosphere, and will be reflected when they encounter obstacles, which will cause errors when calculating signal transmission time, and then errors in distance calculations, resulting in positioning errors of tens or even hundreds of meters. How do we solve this problem? The answer is the differential positioning technology. This solution starts by setting a base station with a known position, then a connection through GNSS satellites to obtain a measured position of the base station. From this, the error between the known and measured positions can be calculated. Then, the base station can provide correction signals based on this error to correct other measurements. The impacts of tropospheric and ionosphere's movements on satellite positioning are basically consistent within 20 to 40 kilometers from the base station. Therefore, as long as the correction signals are sent to drones in real time, drones in this range can determine their accurate positions precise to the decimeter or even the centimeter. This is called real-time kinematic technology, also called RTK technology. Traditional RTK technology requires the establishment of a base station for each use, which is requiring much time and effort. Instead, we can establish a network by evenly deploying multiple base stations over a large area. This type of network is known as the Continuously Operating Reference Stations, CORS system. With the composite correction signals sent via the network in real time, drones within the range can perform fast and precise real-time positioning. This is also called network RTK technology. However, signals need to be received all the time when using RTK. The drone may be unable to receive the signals due to the environment effects or no internet connection possible. In this case, we can measure with PPK technique, which means post-processed kinematic. After the positioning measurement, we use software to process data collected from the drone and the base station to compute the accurate position of the drone. So this technique is not performed in real time. In order to make it easier, Network PPK Solution Service is developed in recent years, and the differential data solution can be completed by simply uploading the data collected from the aircraft. When a drone enters areas with high electromagnetic interference, such as areas around electrical substations or iron ore, its compass may get disturbed and the drone couldn't calculate the direction it is pointing, which will usually result in the drone being unstable. DJI Dual Antennas Tech could solve this issue. By having a second antenna to send and receive signals, the drone will receive two sets of data from each of the antennas. Using one data set as the benchmark, it could calculate the precise locations of both antennas and accurate heading. The longer distance between two RTK antennas also leads to the more precise navigation of the aircraft. Above all, the development of positioning technique improves the positioning accuracy, mapping accuracy, and drone safety greatly.
Next, we are going to mention the control stick mode. Control stick mode defines how the two joysticks control the aircraft. DJI drones support three modes, which is Mode 1, Mode 2, and Mode 3. Mode 2 is set by default. No matter which mode you use, remember to check it on the pre-flight check page before each flight for your safety.
The remote controller has two control sticks. Each stick can be moved up, down, left, and right, and will control the orientation of the aircraft accordingly. Just as cars in different countries sometimes have different steering wheel positions, drones can have different operation modes for the remote controller. Controllers can be set to Mode 1, 2, and a custom mode. Mode 2 is the default mode for DJI drones. In Mode 2, moving the left stick up and down changes the aircraft's elevation. Moving the left stick left or right controls the rudder and rotation of the aircraft. Moving the right stick up and down changes the aircraft's forward and backward pitch. Moving the right stick left or right changes the aircraft's left and right pitch. In Mode 1, moving the right stick up and down changes the aircraft's elevation, while moving it left and right changes the aircraft's left and right pitch. Moving the left stick up and down changes the aircraft's forward and backward pitch. Push the left stick left to rotate the aircraft counterclockwise, and push the stick right to rotate the aircraft clockwise. Please note that different operation modes correspond to different operations. Be sure to check the operation mode before operating a new drone. And remember that all DJI drones are set to Mode 2 by default.
People fly a UAV for a purpose. We usually use a payload or a gimbal to accomplish the task. The most common payload is a camera. For DJI Enterprise drones, we have more. These are the cameras or payloads on the DJI Enterprise lineup. Instead of introducing each one, I will talk about the sensors in common, including the wide camera, zoom camera, thermal camera, laser rangefinder, and LIDAR. Wide camera is the most common camera for DJI drones. You can get a lot of information in one photo with the wide angle. For mapping and surveying, we need the wide camera to be more powerful. That's why we packed a large CMOS sensor, more pixels, mechanical shutter, and time sync feature to achieve this purpose. A bigger CMOS sensor means a large pixel size, which can capture more light. A mechanical shutter can let the aircraft fly faster when taking photos and reduce the rolling shutter effect. Take M3E as an example. The mechanical shutter can let it achieve interval shooting at 0.7 seconds, which is much shorter than the Phantom 4 RTK. These are the payloads with wide camera and its location. Zoom camera is essential for inspection and public safety applications. You can recognize the license plate from hundreds of meters away, or follow the suspect and cars from far away distance without being noticed. Or you can have a clear look at the metal parts of the transmission power without being affected by the high voltage. Some models like ZENMUSE H20 series and M30 series can support optical zoom and 200 times hybrid zoom to let you inspect the target from 100 meters away. These are the cameras with zoom camera and its location. The thermal camera can take a photo by capturing the infrared radiation of the target. It can see through smoke or fog, and it can work well at night. For inspection applications, the thermal camera is often used to check the overheated parts or cracks in the concrete. For public safety, it's often used for search and rescue and firefighting. ZENMUSE H20N has two thermal cameras with different focal length, so when you need to zoom in with thermal camera, it can take a better thermal photo. These are the payloads with thermal camera and its location. Laser rangefinder is equipped with ZENMUSE H20 series and M30 series. It can detect the distance between the aircraft and the target. When you use pinpoint feature with laser rangefinder, you can mark the target exactly and get its location. ZENMUSE L1 uses LIDAR technology. It can project and receive millions of laser points in a short time. You can preview the 3D model in a controller, or use DJI Terra to construct a detailed 3D model. ZENMUSE L1 can support high accuracy and is often used in mapping and surveying applications. Thank you for your time.